When studying investments, one of the main categories or items that you're going to be discussing is interest, and particularly compound interest. So in this video, we're going to be showing how you can solve word problems dealing with compound interest. So what is compound interest? In, uh, Simply, it's just interest where you have interest earned not only on the principal, but also on the interest earned from the previous year or previous month. So the equation for compound interest is A equaling P times 1 plus the rate divided by the number of times it's being compounded raised to the NT power. Now the capital A represents your current amount balance. The R is the annual interest rate expressed as a decimal. The N is going to be the number of times interest is compounded each year. So that could be daily, it could be compounded annually, it could be monthly, it could be quarterly, it could be semi-annually. We have T, the time in years, and then P is the principal amount or the initial amount invested. So example 1 says Roberto invests $375 in a savings account that earns 1.4% interest compounded monthly. How much money will he have in 3 years? So in here, we have the initial amount of $375. It earns 1.4% interest compounded monthly. So monthly would represent 12 times. So I'm going to put a 12 here. Monthly means 12 times, so that's our N. We want to know how much money will he have in 3 years. So what is his account balance? So we're going to be solving for A here. So I'm going to substitute numbers in here. So what is the account balance when the initial amount, the investments or principal amount is $375 times the 1, and the 1 represents the 100%. So you get your money back plus the interest earned on top of that. So the percent, 100% as a decimal would just be 1.0, so that's why it's the 1, plus the rate as a decimal. 1.4 is a percent. So as a decimal, I have to move the decimal place or multiply it or divide it by a 100. So if I move the decimal place 2 places to the right or to the left, I'm now left with 0.014. So 0.014 divided by the number of times being compounded each year. It says compounded monthly, which means 12, raised to the NT power, which would be 12 times the number of years, which would be 3. Now that I have that, a quick way of doing this is just getting your calculator. So I'll grab my calculator here, and we're just going to delete what I have here just to clear everything. So find the account balance. I have 375 divided by, and here I'm going to put parentheses, 1, actually, be 375 times parentheses 1 plus 0.014 divided by 12 and parentheses. Then I'm going to raise that. And here it's very important. If you're going to put both 12 and 3 in there, then you have to put this in parentheses on the TI-83. On the 84, you may not have to because they'll already put that as an exponential and both of them as exponentials. Here, if I put it as parentheses, I could do that, or I could just do 12 times 3, which is 36, so I'm going to raise it to the 36th power. If you put it as 12 times 3 without the parentheses, it's going to raise it to the 12th power, solve it, and then it's going to multiply that by 3. You don't want that to happen. So it's either you put both of them in parentheses or you just raise it to the one number, do the multiplication first. So that's going to give us 391.0758555. So when you're dealing with interest, we want to round it to the nearest cent. That's 2 decimal places. So the account balance would be $391.08. Let me go back to that, $391.08. Now going back to my calculator, I'll show you very quickly. If I put this in parentheses as 12 times 3 and hit enter, I get the same answer. Well, look what happens if I don't put this in parentheses. If I get rid of this parentheses and I get rid of this parentheses, I get 1,140.85. You can see that's a big difference. So make sure you use parentheses appropriately. Next example. Tammy wants to have $5,000 in her savings account to buy a car in 4 years. If her bank offers 3.5% interest compounded quarterly, how much should she invest now in order to buy her car? So we're given what her account balance is going to be. So this is our A. The T is 4. The interest is 3.5%. Quarterly means 4. That's our N. We want to find how much does she invest now. This is our P. So to solve this one, I want $5,000 in the account. The principal amount, I don't know. That's what we're trying to find. So I'm going to use P there. Times parentheses 1 plus the rate as a decimal, be 0.035. Divided by quarterly means 4 times a year. Raised to the 4 times 4. And then I'm going to simplify this a little bit before I solve for P. So this is going to give me 5,000 equals P times, and then I'm going to use my calculator to simplify what I have here. So that's parentheses 1 plus 0.035 divided by 4, and parentheses raised to the 16th power. That's going to give us 1.149573552. Now, to be as accurate as possible, I actually want to use all of this. So I'm going to divide all of this by here, so 5,000. So on my calculator, what I'm going to do is I'm going to type in 5,000 so I can get that P by itself. So I'm going to divide 5,000 by, and I'm going to hit second answer, which is what I just have there. And that will give me my answer of $4,349.44. So the principal amount she should invest would be $4,349.44. I believe that's what it was, $49.44. So it's very important that you read carefully what they're asking you to find so that you can be solving for the correct variable. In the last part of this video, we're going to look at compounded or interest compounded continuously, also known as the PERT formula. So interest compounded continuously uses the formula A equals P times E raised to the RT with base E, which is Euler's number. So example, Katie puts $900 in a savings account that earns 1.2% annual interest compounded continuously. How much will her account be worth in 5 years? Write an equation to represent the problem, then solve your equation. Now the difference between compounded continuously and compounded just regular compounded interest, would mean there is no set time period for continuously. It's just consistent. It's constant over time. It's not like quarterly or monthly or daily. It's just one continuous flow. So that's why we're using a different formula with Euler's number. So here we want to write we do want to write an equation to solve it first. So we're trying to solve for A when the principal amount that she's investing is $900 times, we have Euler's number, so I'm going to use base E raised to the rate as a decimal, so this would be 0.012 times the time in years, which is 5. So that would be our equation here. Now to solve it, I'm going to grab my calculator again. So I have 900 times, and then Euler's number. So if I hit second, I could hit second in division, or I can hit second ln, the natural log button, and that's going to put that as base E raised to a certain power in parentheses. And then I have 0.012 times 5 end parentheses. When I hit enter, you can see that I have $955.65. So A would be $955.65. And that's how much she would have in her account after 5 years. So that is our video on working with compound interest and compounded interest continuously.